In today's lesson, we are going to do something called a regression. So again, regression is basically we are taking a set of data and finding which equation, which function would best model that data, and then allow us to predict future values based on the pattern that we find. Now, we're going to compare two different kinds of regressions. The ones that we do most often are going to be quadratic and exponential. So those are the two that we're going to focus on today. However, if you would like to see how to do additional regressions, you are more than welcome to let me know. I'm happy to show you how to do those on either the Desmos calculator or on the TI calculator. Now, the first three problems that we're going to look at are actually Desmos regressions. So that's this first half of the video. This is why I'm splitting it into two parts. So if you're using a TI calculator, I would absolutely watch the second video, but then try out problems 1 through 3 on the organizer and then see how your solutions from your TI calculator compare to the answers I get on the Desmos regression. So we have 3 sets of data that we're going to look at, and we need to know how to plug these in. So let's go ahead and change over to our Desmos screen. And again, you're going to want to make sure if you did not print out the organizer, if you don't have a printer, you're going to want to pause the video here and actually go back to the organizer and jot down the table of values that I have for each problem. So let's pop over to Desmos. And if we're going to be trying to determine the difference or the best regression, we're actually going to do 2 regressions at the same time on this. Before we do either, though, we need to put in our data. So for our first problem, we're given a table of data that gave us the side of a square versus the volume of the box that would have been created. And this is not going to be, a perfect, square box. This is just our data saying, here's a square side on the box. And then here's the volume that we would then look at. If you've ever ordered anything online, you've noticed it very rarely comes in a perfectly square box. So to enter our data on Desmos, you're going to want to hit the little plus sign, and you have a number of options come up. We're going to enter a table of values, and it automatically populates this with X1 and Y1, and that's going to be important in a second. So now I'm just going to type in my data. So we have 1, and again, you can just type this in by hitting the tab button if you have a keyboard. I'm showing you how to do it on a touch screen just in case. And then we have 58.5. Then I hit enter. And again, I might use my arrows to go around, and then we're just typing in. So we have 1.25 and we have 63.75. Oops. And we had 1.5 and 66. And again, I'm on a touchscreen computer, so I can actually just click on the space that I want to type into, or you can use your arrows on your keyboard as well. We had a 2 and a 63. We had a 2.25 and a 58.5. Excuse me, 0.5. And then our last value was 2.5 with 52.5. And it's always a good idea to pause and make sure that you typed everything in correctly. Make sure you don't have any typos. Big thing to do on TI calculator as well, especially if you're trying to type these kind of quickly. Alrighty, so we're going to do 2 regressions at the same time so we can pick out which one is best. So first regression we're going to do is, again, we're trying to determine, is this a better fit for a quadratic or for an exponential? And why do you think I'm picking those 2? Well, real quick, let's actually check out what our data looks like. So we have our X values go from 1 to 2.5. And so, but our Y values go from 58, ranging all the way up to 65 and then back down to 52. So I have a feeling this is going to be quadratic data. It's going to look like a parabola, but we need to see what that picture looks like. To change your window size on Desmos, hit the little wrench key, and then you can set how far your x-axis and y-axis go. So my x-axis is actually pretty decent right now. I'm not going to play around with that too much, but I do want to set my y-axis so it goes up to at least the highest value, if not a little bit. So it looks like my highest value on here is 66. Let me bump this up to 70. And so there's my data. And again, I want to make sure I can do this because seeing the overall shape of the graph will give me a better viewpoint of which one I need to pick. I'm still going to do both a quadratic and an exponential regression though, just to see how, if you're not quite sure looking at the data, how you can pick this out from what Desmos spits out from our regressions. So first one, let's do a quadratic regression. So in a new space, we actually need to type y with a subscript of 1. Now, the neat thing with Desmos is it automatically assumes that that's what you're referring to. And in our list right above, they actually called those y values y1. So it's already referencing that list that we had. So to say that we're going to do a regression, we actually need to type in a little tilde. So like what you might put over the N in Spanish. To get to that, hit that little, ABC to toggle between your keyboards, and it's down on the bottom level with that little tilde, or on a regular keyboard, it's right above your tab key right next to your 1. Okay, we're going to use standard form, which means ax squared plus bx plus c. So we have an a, and then I need to type in x, but I need to do x sub 1. So same thing, if I just type in a 1 right next to it, it automatically assumes that's what I'm referencing. Alrighty, so then we need plus, oops. If we're doing a quadratic though, I need to square that, right? And so again, you have a squared up on that piece. You can put both a subscript and a superscript in the same spot. Alrighty, then we need bx 1, and then we need c. Oops, I left out my plus sign, so let's go back to this and use my arrows, plus. And so you'll notice what Desmos did is it went ahead and took the data that we put in our chart for the x's and the y's, and it created what it thought was the best quadratic to hit every single point that we plugged in. And you'll notice it actually gives us this statistics thing. So this r squared, that's what tells us how good our regression is. So if this number was equal to 1, we would have a perfect fit with our data. So we're trying to get this as close to 1 as possible. So I know that this is quadratic data. That's just the picture that we have. But just to show you how this would compare if we don't have the right regression, let's go ahead and program in an exponential regression just to see how this compares. And I can do this with exactly the same set of data. So I'm going to start the same way. So y1 to show, hey, I want to use that same list that we put in before. And then I need my tilde. And exponential format, we're going to go pretty basic with this. We're going to go a times parentheses b raised. Oops, I don't want to do squared though. So I'm going to use a raised to the b because that just pushes my cursor up, and then x1. So again, it's saying, hey, use the x1 and y1 data that we plugged in before, and then generate these values for a and b so I know what my best equation is going to be. Alrighty, and so if you look at your r squared there, I know that my exponential graph does not hit very well. You can even look at what it graphed on our picture, and yeah, that did not come out very well. Our r squared value is at 0.2355. We're trying to get as close to 1 as possible. So exponential data does not fit for this very well at all. We definitely want to use our quadratic data, so on the red graph. And so that is what our expression is going to be. And so we would want to go ahead now and write down the equation. So let's pop back over to our screen. Let's make sure I have everything written out properly. Beautiful. Alrighty, so back over to Desmos. And so we're going to say regression type. Well, we're going to use quadratic. That one had the best r squared value. And our regression equation was that y was approximately negative 18x squared plus 58.5x plus 18.375. And again, I'm just substituting in what I saw on Desmos that they had for my A, B, and C values. So the last piece of this is we want to predict what the volume of this box is going to be if we had the side length of 5 inches. And so we don't have that value actually, excuse me, 3 inches. I updated that on the graphic organizer that you actually have. So as I'm looking at my table of values, I don't have 3 in there. So let's actually go back to our graph and see if we can just look up this point. So if we're looking for 3 inches, then that means we're looking for what are the x coordinates, or if the x coordinate is 3, what's my y coordinate going to be? And so nice thing about Desmos is I can just, if I click on my graph, so on our red expression, our red function that it came up with, I'm just looking for where do I have the perfect 3x value, and I can just slide along until I get there. Now I could also absolutely plug this into my calculator, plug in 3 for the x into the equation we created, but let's use the tool we have available. And so it looks like at the point 3, or when x is equal to 3, our y value is going to be 31.875. So that's going to be our volume of our box. So let's write that in. Oops, new share. So back to our PDF reader. And so our volume at 3 inches is going to be approximately 31.875 inches cubed. And again, it's an approximation because our graph isn't necessarily perfect. We didn't have an r² value of 1, so we know it's really, really close, but not exact. Okay, let's do our next one. So our next set of data, we have time versus population of bacteria. So if you've taken biology, you know bacteria grows at a pretty steady rate. And so just before we plug anything in, do you think this is going to be quadratic or exponential data? Yeah, I think it's going to be exponential data, but let's test it out. And so since we already set things up on Desmos, again, I know I'm popping back and forth. This is why you really want to have this jotted down somewhere. I already have everything set up, so let's just modify our chart, our table of values that we put in at the beginning. So up on our table of values, I'm just going to start typing in new values on here. So my first expression I had is a 0, and then we had 250. Then we had 1 and 330. And now actually it wouldn't be a bad idea. Go ahead and pause the video and try plugging this in on your own. So I'm going to pause the recording just so you're not watching me type stuff in. Alrighty, so I've plugged my data in, but I have this extra row in here. So all I'm going to do is click on each one of those spaces and just delete that data out. I can still use that list though. But I do need to modify what size my screen is because I can't see all my data in there. So again, go to your wrench button and then play around with your values. So again, I'm not going to play around too much with my X's, but my Y's, we're going from 250 up to 3,000. So I'm going to go ahead and kick my Y actually even higher than that. Let's go to 3,500 just so we get a good viewpoint of what's going on. Alrighty, so close my keyboard, close my settings. So because we already had our regressions plugged in, we don't have to retype anything, which is really nice. And so looking at what the computer came up with, it looks like the blue graph, which is my exponential regression, is hitting the data better. The quadratic isn't too shabby, but again, look at your r² values. So your r² value on your red graph on our parabola is at 0.9849, pretty good. But the exponential, the blue graph, is even better, 0.9946. So that's definitely the one that we want to end up using. Now, when I write this out, I'm looking at my A value and my B value. My B value, 1.79998. Yeah, and I can write all those decimals down. I'm more than welcome to do that. But as I write it down, I'm going to go ahead and round to 1.8 when I write this out. And so then the last piece is, our problem wanted us to predict the population of bacteria after 7 hours. So again, we could just plug that into our equation as needed, or again, just make sure we're looking at the correct graph. Our exponential was definitely the better graph, so I'm actually going to turn off the red graph so I don't accidentally use that one. Just click on the little red with the squiggly, and that actually turns the graph off, and all you'll see is your exponential graph. And so again, I'm going to have to move my graph over a little bit to get to my x's. You can actually pinch and zoom if you have a touchscreen computer. But I'm looking at this, and it looks like I'm going to have to go much higher on my values. So let's actually just bump that up. Let's put this up to 5,000 just in case. Gives us lots of extra room on there. So again, click on your graph and then keep dragging. Ooh, I need to go even further, don't I? To get to 7, I'm not going to have enough space on there. So let's go even further. Not a bad idea to help this out with predicting our graphs. Let's go up to 7,000. Alrighty, that will definitely get us there. So our 7 is right kind of, oops, not even quite. I'm going to go ahead and just scroll up a little bit. And then again, if you just take your mouse and start scrolling along the graph, you're looking for where your x coordinate is equal to 7. I'm getting pretty close. There we go. So exactly at 7, we're looking at 9,657. Sorry, I'm trying to get my touchscreen stylus in the right spot. There we go. So 9657.35. Now, if this is bacteria, again, that means we actually want to round that down. We're looking at single instances of bacteria. So 9657 is what we want to write in. So let's pop back over to our notes. Okay, regression, exponential worked the best for this. Our regression equation was y is approximately 157.754 times 1.8. Again, that's rounded, raised to the x. And our population after 7 hours was approximately 9,657 colonies, I guess, or instances of bacteria in that colony. Alrighty, last example. So again, time versus concentration of blood. Here we go. We're going to type our data into Desmos and then do our regression. So again, I'm going to go ahead and pause the video while I type this in, just to save a little bit of time. Alrighty, so to make sure we can see our data, again, let's modify our screen size. Looks like our x's go from 0 to 2.5, which we don't need to mess around too much with. Our y values, we start at 0 and we jump all the way up to 78 and then 92, and then we start falling back down. So let's maybe set our y values at 100 and see where that gets us. Our y's probably don't need to go down so far, so let's go like -20 to +100, and we'll see what that gets us to. And again, we're comparing between quadratic and exponential data. So let's go ahead and turn both of them on. And yep, our data definitely fits a quadratic better for this. Again, check your r-squared values. It's extremely important. Your exponential r-squared value is 0.000. It is not a very good regression. So we definitely want to use our quadratic regression on this. And so we have, again, upside down parabola. And to find our value, again, easiest way would just be, find the point on your graph or plug it into your equation. We're looking for what is the concentration at 2.25 hours. So just over 2.25. Oops. 2.25, we are at about 37.9. So 2.25, 37.9, or approximately 38 milligrams per liter. Alrighty, so let's go write that down. So our regression type was quadratic, as that had the best r-squared value. And our equation was that y is approximately -54.1286x squared plus 134.516x plus 9.35, again, negative a value to show the upside down parabola. And so our concentration at 2.25 hours was approximately 37.984. So as always, let me know if you have any questions. Feel free to try out the last 3 problems on Desmos and see if it compares with what I come up with on the TI graphing calculator. But if you're ready to go, keep going with your Desmos activity.